Hello, everyone.
Hello.
So thank you all for being here for this webinar on which we're going to try to give you all the insight we have on how our customers are using drone for their research trials. So let's go. So first, Hiphen. Well, Hiphen is a company that has been founded 7 years ago and that is specialized in the plant measurement using sensors. We'll introduce that a little bit further later on. And today we're having Alexandra. Hello, Alexandra.
Hello.
Which has a PhD on all what is food processing, and myself, which is the founder and CEO of Hiphen and specialist in all what is high throughput phenotyping. You can see some pictures of all the Hiphen team. Today we have a team of 20 engineers really motivated in all what is phenotyping, and I guess we really made a real pool of expertise within Hiphen.
So as you may know, at Hiphen we acquire data with a wide range of different sensors like as drones, but also satellites or phenomobiles and so on and so on. And then we compute the data to turn it into agronomic traits thanks to our deep knowledge in artificial intelligence, but also in the mechanistic crop behavior, so that in the end you can make the right decisions about your field trials. Today, drones are the most affordable and versatile devices that are used for high throughput plant phenotyping. And at Hiphen, we process a wide range of different traits, either mechanistic traits or traits which are based on artificial intelligence. So if you are interested in all the traits that we process, you can have a look on our webpage where you can find several specific webinars.
So today, maybe we're going to precise that we're going to really focus on research trials, and that's already a really vast environment, which is research trial, because a research trial can be wide or small, made of small, like half a square meter, or hectare plots, or micro plots in French, and it can be used by different persons, different companies in the ag space. So it can be used either by breeders, either by companies looking for crop protections, either by companies processing food, either by companies trying to advise farmers and crop production to make support management tools, etc. So you can really have some trials that are made of 20 plots and that looks big, and other trials that are being made of 10,000 plots and that look small. It's really very diverse. And once we said that it's very diverse, it means that the uses of those research trials are diverse, and so the use of drones can also be diverse. From our understanding, in seed breedings, there's two main things you're interested in, is to know your trial quality, at the same time at the microplot level, but at the trial level as well, and to make some genomic predictions, not only on yield, but also on some traits derived by the drone. Regarding of crop protections, and especially today biostimulant, etc., the idea is to assess the quality, the efficiency of your products, and it's a big deal since biostimulant and biocontrol product are rising so fast. Agro production and agro processing is really about yield prediction. So at the same time, quantity and quality. So what is going to be the quality of my harvest? Or am I going to be able to process it like I process it? I mean, the example on wine, or am I going to have too much disease, too much fungus, etc. So it's not only quantity, but it also can be quality. If you see other use case, please don't hesitate to share those thoughts with us on the chat. Us today in this webinar, we're going to try to detail to you those 4 use cases we proposed here, and to give you the insight on how we're managing it with our customers. So let's start with the first use case, which is a drone for trial quality assessment. Alexandra, can you tell us more?
So I'm going to tell you why it is so important to assess the quality of your plot as soon as possible. In the first place, breeders are interested in the yield, but you know that the yield cannot be directly acquired by drones. However, finally, the measurement of the yield may not represent the reality because there are a lot of different limiting factors which do not depend on the genomics of your crops, which will have an impact on your plot quality. So if you have the possibility to assess the quality of your trial as soon as possible, you will know if you can trust in your data or if there may be some signs that recent trends or events, such as maybe some specific weather conditions or pest infestations, will make your trial results unusable. So if you finally decide to stop your trial, you will save a lot of money. At Hiphen, we can also advise you at which physiological stages you should assess your data in order to make the most valuable decisions. So for an example, with drone data, you can evaluate the plot quality. So for example, in plot 2, you can see that your field or your plot is really homogeneous. But in plot 1, you can see that there are some gaps. So this may be due to emergence issues. It is also important to know that the way we assess the plot quality depends on the crop. So here's an example for a big plant. So for example, maize, but it could also be sunflowers. And here we focus on the emergence of the plants. So we can count the different plants on your plot, but we can also detect some gaps. Further, we could also detect border effects. So this means if your plot influences maybe some neighboring plots. And we can also detect weed, because weeds will compete with your crop, which will finally reduce the yield. Another example is wheat. At an early stage, we can assess emergence issues. Later on, we can also evaluate plant lodging or some other unexplained issues, which often depend on pedoclimatic conditions.
Thank you, Alexandra. So that's really the first use case is about trial quality. And to be fully honest with you, that's where we make the most contract with breeders today, is really to be able to assess this quality at the same time at the microplot level, as it was demonstrated, and also at the trial level. The other use case that has been a lot investigated and discussed, on which we are working a little bit, but in less massive amount, is using drone to make genomic prediction, and thus to speed up breeding processes. So there, how to explain that? Well, I think in a very simple way, I like to present a successful use case. The successful use case is a Nobel Prize winner that did that, which was Norman Borlaug. And basically what he did is, instead of breeding directly on yield, he said, I'm going to breed on crops that are having smaller heights, so dwarf wheat, but that preserve their biomass, and as well as some that has disease resistance. And this allowed them, even if it's not directly correlated to yield, well, to increase yield massively around the world and to win the Nobel Prize. And so when you try to generalize what Norman Borlaug did, well, you have this equation of a breeder where basically yield improvement is a function of section intensity, section accuracy, genetic variance, and years per cycle. The breeders has been awfully efficient in reducing the years per cycle and the genetic variance, and sometimes much less efficient on section accuracy and section intensity. When we speak about checking the yield quality in the first use case, it's also to be more accurate in your selection. Another way to be even more accurate is to select on another trait, which you know that is somehow correlated to yield. Could be an agroclimatic trait, for example, and we can discuss that further. Easy and precise to assess, at least more precise than yield, and more heritable than yield. And so this is something we already did with some customers, and we published some results in 2019, and we really invite you to go and see this paper, which is entitled A High Throughput Model Assist Method for Phenotyping Maize Green Leaf Area Index using Dynamics through Unmanned Aerial Vehicles. And basically there, what we showed was that green leaf area index is more heritable than yield, is quite correlated than yield, and is let's say easier to assess. Even this can be discussed a little bit further. Another use case which we're currently working with in RAE is senescence speed on sunflower, where we showed that we had a real genomic variance and correlation, excuse me, and it's something where we're going to work further and probably make a webinar in the coming month. Finally, and that's, I think, the important thing, a lot of breeders are sometimes a little bit doubtful about what I call Norman Borlaug method, and are putting that into question, saying, hey, we don't care about those proxy traits that are related or correlated or whatever to yield. What I want is only to make yield improvements, yield improvements, yield improvements. And so me, what I care is about my equation, yield is genetics, my genetic potential of my crop, times the environment, so times the condition in which I can grow it. And they try to make models out of that to better explain yield and thus to better select the genetic SNPs or whatever that they have. What we see there, and we haven't worked directly on it, but we made bibliography and we have been discussing that with customers, is that probably using those traits, agroclimatic traits and traits derived from drones, would allow you to have covariates to improve your model. And that would be really, really useful. So most of the publication I'm aware of are more speaking about crop models. But using drone data, we can have some parameters that are similar to the one derived by models, and that can actually really improve your modeling of the yield by genetic times environments. So that's all for this use case, at least in a glimpse on the 30 minutes we have together. Let's look to the next use case.
So in the third use case, I'm going to show you how you can use your drone data to evaluate the impact of your crop protection products on your trial. So before, we used a lot of chemical products which were really efficient, so it was enough to only estimate the yield. But today we use more and more biocontrol and biostimulant products, which are more eco-friendly, but also less effective. So here, one product only focuses on one limiting factor. And thanks to drones, or drone images, you can investigate these specific yield-related traits that your crop protection product is having an impact on. So as you may know, you can either directly measure each factor which will limit your yield. So for example, pest infestations or diseases, but this is rather hard. So it is easier to monitor the impact of the limiting factors indirectly by studying the impact on different biophysical traits, for example, vegetation indices, or the number of the plants, number of plant organs, flowers, and so on. And so at the end of the day, we can evaluate if your product is really efficient, but also you can understand more how it works. So this direct assessment is really easy to do with drones, and this is exactly what we already do routinely at Hiphen. However, sometimes the drones may not be the best device to assess indirectly the limiting factors. For example, it depends on the plot size, which device will be the best. So at Hiphen, we can also advise you which device should be used. And of course, we can also process images from a wide range of other devices. For example, satellites. Here you can see a huge field. So satellites are are a good device, for example, for the assessment of nitrogen. Thanks to the vegetation indices, like here, for example, the NDVI, we can know if your product, in this case nitrogen, is efficient and also when to use it. So there are a lot more of other use cases. And if you have an idea or maybe a specific problem, don't hesitate to contact us.
Thank you, Alexandra. So I think really the important thing you need to really have in mind here is that this type of use cases on nitrogen is used to make support management tools. Support management tools for what? To try to advise the farmer or the company if he should put more or less nitrogen. So here you can see the nitrogen enriched strip. What means that when you're trying to make some drone yield predictions, which is the next use case we're going to present you, and the last one, it's generally done to try to evaluate, to help evaluate how to make your how to use your products in the case of products, or your genetics, or your cultivars in the case of cultivars, in the most efficient way in your production cycle. And for that, for yield prediction, I really think that the main idea is to think as limiting factor. And how can we think as limiting factor? Well, first, any types of crops that we're speaking about, corn, barley, rapeseed, sunflower, or whatever, it's always the same thing. What the hell is yield? Well, yield is the quantity of biomass that was accumulated during the year, times the harvest index, the capacity of a plant to transform the biomass into what you're going to harvest. In case of sugar beet, it's sugar. In case of wheat, it's grain, etc. The harvest index is very hard to evaluate with sensors. However, the biomass can be assessed through either if the limiting factor is light, like in this example, where the quantity of light intercepted by the plant times the radiation use efficiency. Radiation is use efficiency that is sensible to other limiting factors, otherwise it's fixed, which the quantity of energy intercepted by the canopy is directly linked to the quantity of LAI, etc. But you can see that if the limiting factor was water, by example, it would be the amount of water that rained or that was irrigated onto your crops times the water use efficiency, and it will work exactly the same way. Well, here, to estimate the amount of LAI, we already published on that. We're able to assess that through drones, and so we are able to assess this limiting factor, which is the biomass accumulation through time. This is not enough, however, because there's other limiting factor, by example, the harvest index. If we take the case of barley, by example, well, in the case of barley, if you don't have enough ears and enough grains, you can have a lot of biomass. Your conversion of your biomass into grain will not work because you don't have the grain in order to have a proper harvest index. And this can be a stress like cold, frost at bad timing, diseases, or many other things. And so how are you going to capture those other limiting factors linked, by example, to harvest index? Well, there you're going to need to make a modeling specific to your crops. So let's take the example of barley, but we could do that with any types of crops. Well, yield is what? Yield is, well, the surface on which you're measuring your tons, your quantity of tons, times the number of heads of barley heads you have, times the number of kernels per head, which is quite fixed actually in the case of barley, less in the case of wheat, times the weight of those seeds, of those kernels, which we call in the agronomical world the 1,000 kernel weight, because that's what we're able to measure. And there, we also made some publications there. We're able to count the number of heads, by example. So we're able to assess this limiting factor. Am I having a lot of barley head, or am I having less, which is really important combined to biomass, etc. By having all those limiting factors that you're at the same time able to assess through weather stations, through drones, and maybe through other ways, And by putting them together through artificial intelligence, which actually is nothing fancy, it's just another way of seeing a linear model. It's a non-linear model, but it's nothing more fancy than that. We're able to construct for your use case some really efficient yield prediction that are going to be able to be used either to make some support management tools, either to give you some more insight on your cultivars, and to be able to detect outliers, etc. So that's really the last use case that we wanted to show about things we're doing with our customers to be able to use drones data in your research trials.